Thanks everybody. Thanks for showing up at our talk. So I am uh, supposed to give this talk with my co-speaker Priyanka Saggu, but she just arrived in London today, so she was not able to make it. So I'll be giving this talk entirely by myself. And yeah, let's get right into it. So this talk is about common expression language. So common expression language, or CEL as we call it, is something that is up and coming in Kubernetes. And yeah, this talk is about how CEL is shaping the future of Kubernetes, and how we are able to extend Kubernetes with CEL. So who are we? So my name is Sreeram Venkitesh. I work as a senior software engineer at DigitalOcean. Priyanka Saggu, my co-speaker, she works at SUSE as a Kubernetes integration engineer. And yeah, this talk is based upon our work from the past like 8 or 10 months. So before I start with the talk, I wanted to get some things out of the way. So I'll be using some acronyms and some specific terms which I wanted to clear what they were. So CEL obviously stands for Common Expression Language. When I say CEL upstream, what I mean is the Google CEL Go package, which is used to integrate Common Expression Language inside Kubernetes. CRD obviously stands for Custom Resource Definitions, and KEPs are Kubernetes Enhancements Proposals, which are how new features added to Kubernetes are tracked and added to the release. So the agenda of this talk, we will look at what CEL is, how CEL is used in Kubernetes today, and how CEL itself works, like how the expressions are compiled and parsed and all of that. We'll look at how CEL evolved in Kubernetes over the last 10 releases, and towards the end we'll look at what we were working on with CEL, which is adding CEL to custom resource definitions, additional printer columns. So the major focus of this talk would be the last 2 points, where we talk about how CEL is being used in Kubernetes today and what we are trying to do with it. So what is CEL? So all of these statements I've taken from the Google CEL Go repositories README file. CEL stands for Common Expression Language, and it is developed by Google. And it is a lightweight scripting language which you can use to evaluate expressions within your Go programs. Well, not just Go programs, like any program, as long as the language support is there. So this is how a CEL expression looks like. If you have a variable called name, you can check if that string starts with a particular letter, or if you have a list of strings, you can check if all of the elements in that particular array starts with a particular character, or if they are under a particular character limit, and so on. You can find, so in all of these slides, I have links at the bottom of the slide. You can see more examples and find more information related to each slide. I'll share the slide deck at the end. So before I go into how CEL is used in Kubernetes today, I wanted to give a an example of how we write CEL expressions in Kubernetes. So these are some things that we can do with CEL in Kubernetes today. Like you can work with the information in your spec or status of your workload and so on. So let's look at a few metrics to see how a few metrics to show how CEL is quickly becoming relevant in Kubernetes today. These are the list of Kubernetes enhancements proposals which deal with CEL. So there are about 11 features which are actively adding CEL functionality to Kubernetes. And yeah, when I search for CEL in the Kubernetes code base issues, I can see 6 pages of issues, and the latest one was created very recently. So CEL is area where active development is happening in Kubernetes. And we also have a API machinery CEL dev channel in the Kubernetes Slack workspace if you're interested in reading the discussions that are happening about both using and integrating CEL into Kubernetes. And again, one more example I wanted to show to show how CEL is used in Kubernetes today. This was a CVE that was reported recently, and one of the solutions to mitigate this vulnerability was to use a validating admission policy, which in turn uses CEL to, in this particular example, it uses CEL to restrict pods. So this is a vulnerability with the Git repo volume, so you can make sure that the pods created are secure using CEL. So now let's look at how CEL works, because I've been talking about CEL for quite some time now and I've not really gone into the details. So this is at a very high level how CEL expression evaluation works. We have a CEL environment where we can define all of our variables, and we compile our expression against this environment. And at this stage, we'll type check all the variables and check if the expression itself is like valid. And if that compilation is successful, we get an abstract syntax tree, which we can convert to an executable program, and we can evaluate that program against our inputs. So we'll take the example that we had in the first slide, and we'll walk through all of the steps with the necessary code. So I'll be writing a Go program, which will take a CEL expression and compile it, and then evaluate, it will evaluate that expression against a particular input. So the first thing I do is I import the CEL Go package. I hope the font size is legible. So once we have the CEL Go package, we create a new CEL environment, which we can do with cell.newEnv, and I pass a variable here, which is called name, and the variable has a type of string type. So name essentially takes strings. So once we have the CEL environment, we compile the CEL expression that we had, which was, we were checking, the expression was checking whether name starts with the character A, and we pass that expression inside env.compile, and we compile that CEL expression to get an AST. So at this point, like env.compile is just syntactical sugar for env.parse and env.check, which are two different methods which are available. So env.parse will check if the CEL expression is if the syntax is correct, and env.check would type check the expression against the variables that we've defined in the environment. So if we are trying to do starts with on an integer input, then it would fail at that stage. So env.compile just does both of those and gives us the errors if there are any. And once we have the AST, we can convert the AST into a program, which is what we do with env.program. And once we have the program, we can call program.eval, and we pass the list of our inputs. So here I pass the name as Alice, and when I do program.eval with this particular input, since our expression checks whether the name starts with the character A, it returns true. Yeah, that's how CEL works. But now let's see how CEL is used in Kubernetes. So CEL was first introduced to Kubernetes 10 releases back. We are now in the 133 release cycle. CEL was first introduced in the 123 release cycle as a way to write custom validations for custom resource definitions. So this is the release blog post for the 123 release where the feature was introduced. And I will show how the CRD validation itself works, but this is we are quickly going through the pull requests that added CEL support. So this is the first PR in Kubernetes which had anything to do with CEL, and what they've done here is they've copied over some logic, some models, and environment from the CEL Go package in Google. So they added CEL in a wired off state. So all the necessary vendor files were there in Kubernetes, but it was not being used anywhere. So this is the PR that does that. This was created in I think this is merged in November 2021, and the next two PRs that we have adds wires up CEL the logic that we added in the previous PR with CRDs. So as part of this PR, as you can see the commits that have been highlighted, it adds this particular commits wires up the CEL compilation logic with CRD schema. So what happens here is essentially everything that we saw with the earlier example, where we take the CEL expression, compile it against an environment, and evaluate our input on that CEL program. Essentially that happens here, but the input is the Kubernetes structural schema of the CRD, and the validation rule checks where, we can write custom validation rules. We'll go into that, and that is what is being done in the highlighted commit here. And in the further commits, what what is happening is this is wired up with the validation logic of CRD. So along with everything else, we will execute our cell program as well. So this is how that particular feature looks when you actually use it. So this is an example CRD, and at any block of the schema, the OpenAPI v3 schema, you can define an X Kubernetes validation field, which takes a rule and a message. So the rule here is a cell expression, and here the rule checks if self.replicas is in between like min replicas and max replicas. So if this validation fails, we can show an error message, which is what is defined in the message field. It says replicas should be in the range of min replicas to max replicas. So essentially that validation logic is like encapsulated in this particular cell expression. So before the advent of cell, if we were to write custom validation logic such as this, you would have to like it is not as straightforward. You might have to like deploy your own webhook server and so on. So cell makes it easy and adds this extend, like it makes it easier to extend the Kubernetes API server, and it adds like native support for that in the API server itself. So once this feature was done, yeah, so this was alpha in 123, it graduated to beta in 125, and it graduated to stable or generally available stage in 129. So if you're using Kubernetes today, and if you're using a version above 129, cell validation for custom resource definitions are enabled by default. And once this was done, in the first PR that we saw, the cell logic that was added to Kubernetes was specific to custom resource definitions, but later this was moved to its own package, and now cell can be used anywhere in Kubernetes, and all the keps that we saw in the earlier slide adds cell support to different areas of Kubernetes. Like today, dynamic resource allocation is also using cell in some manner. So I have like two specific examples of how cell is used in like different parts of Kubernetes. So we have as part of admission control, we have we used to have validating admission webhooks and mutating admission webhooks. So what they did is if you want to write custom validation rules for your pods, let's say you would have to write the validation logic in a webhook server, and you'll have to deploy and maintain that in your cluster. But you can now do it with validating admission policy instead of validating admission webhook. So what validating admission policy does is you can like define expressions using cell, and this validation would be enforced across your workloads. So in this particular example, we are creating a new rule to we are creating a new rule to validate whether all our deployments have at least 5 replicas. And if we try to create a deployment without with a replica count less than 5, this validating admission policy would fail, and we'd show an error message. So similarly, we also have mutating admission policy. So this particular example uses cell expression to check if a pod that we are applying to the cluster has an init container for a service mesh, and if it is not present, it applies this patch to add that init container. So cell is being used to identify which all containers have that init container or not. So that is an overview of how cell is used in Kubernetes today. So now I'm going to talk about what we have been working on with cell. So we've been trying to add support for cell in a new area of CRDs called additional printer columns. So I'll explain what additional printer columns are and what the what difficulties we are facing with it today and how cell can improve it. So essentially, additional printer columns lets you define what all columns should be printed in the output when you do kubectl get custom resource. So this is how it looks. So if you have a custom resource definition, and when you do kubectl get my CRD my resource, this is what you see. So these different columns are defined with cell. So if you have a CRD for let's say Argo CD app sets, when you do kubectl get app sets, you would see a list of columns, and they are all defined in the CRD definition. So this works today for querying, but if you want to work with more complex data and if you want to do like conditional operations on this data, JSON path does not let us do that. So there have been a lot of issues which have been created, like where people face this issue, and people wanted to use JSON path to write complex expressions, but they were not able to. Like JSON path does not let you work with arrays, and yeah, in this example, like we cannot show duration. So if we have like a creation timestamp, and if we want to get the duration from that timestamp, like JSON path is not able to do that. And yeah, if we have like a list of items, we are not able to show all of them. So let's say we have a list of IP addresses. JSON path is only able to show the first item in that list. So those are all like limitations of using JSON path. And yeah, these are some examples. There are a lot more issues. This is an entire list of all the issues where people have like people wanted more out of JSON path, but they were not able to use JSON path to fulfill their requirements. So this has been like an issue for a long time, and people have tried to solve this in the past. People have tried adding like support for complex JSON path which can work with arrays and so on, but because of several reasons, none of these were like merged. So in this particular comment by Nikita was one of the contributors who worked with CRDs a lot. She mentions that it is not a safe approach to extend JSON path in this way to let people do whatever they want. So this was the case like around, like this was in 2018, so that is like, what, 8, no, not 8, like many years ago now. Yeah, I can't do math right now. Yeah, so this was the case back in 2018, but now that we have CEL, we can make use of CEL to like do all of this and more. So we started a new Kubernetes enhancements proposal called CEL for CRD additional printer columns, and what we propose is adding a new expression field along with JSON path in such a way that you can define additional printer columns using either JSON path or expression, which is, in this case is a CEL expression. And the API server would compile the CEL expression and execute this CEL expression against all the custom resources when you query for them. So this is how the kubectl explain output looks once we added that field. I don't think this font size is legible, but what we wanted to show here is that the CRD additional printer column definition now has an expression field along with JSON path. And yeah, I have a quick demo to show you. So this is a simple CRD called shirt. Let me know if you are not able to read this. Yeah, this is a simple CRD called shirt, and shirt has 2 items in its spec. It has a string property called color and another array of integers called sizes, and these are the additional printer columns that I've defined. So earlier, if we wanted to show the list of sizes, which is an integer array, that was not possible with JSON path. So if I try to show spec, so here spec.color is a string, and we are able to display that, like we are able to add an additional printer column for spec.color using JSON path. But if I want to show spec.sizes as a JSON path query, that does not work. But we have a string for the color. Since this is just querying the data and displaying it, JSON path works fine. But if I want to write a more complex expression, say I want to check if this custom resource has a value for spec.sizes, and if that is present, then I want to show whatever that value is, or if it is not present, or if it is not set for a particular CRD, sorry, a particular custom resource, we want to show an empty array. So this sort of conditional expression can now be like written with additional printer columns, and this is a CEL expression, and this would be compiled by the API server. So I have a cluster running where I have applied the CRD. So before I query it, I will also show you what the custom resources I've applied are. So I have 3 shirt resources. The first one is a color of red and a sizes array of 2, 3, and 4, which is an array of integers. The second one has a color of yellow and it has an array of 1, 2, and 3. In the third shirt, only the color is set. The sizes array is not set since it is an optional value. So I've applied both the CRD and the custom resource. So all these 3 shirts are now created, and now if I query for shirt, if I do kubectl get shirt, I can see that it prints all of these columns that I've defined with the additional printer columns. And here what happens is the first column just prints the color of the shirt, which is querying it using JSON path. In the second column, we are showing the available sizes, and now it is printing an array. And in the third case, since we did not set any value for sizes, it prints the empty array based on our cell expression. And there is a third column which I did not talk about in the CRD definition. So here also we are doing a conditional expression where we check if the sizes is present, and based on that we show true or false. So here, since the third custom resource has an empty array, it shows false. So I have another example that I wanted to show you. So this cell expression checks if spec.color is blue, and if it is blue, then it prints true, or it prints false if the color of the shirt is not blue. So I added this new column called isColorBlue, and now if I apply the custom resource definition, and now if I query for the shirt again, I have a fourth column which basically executes the expression that we just defined. And in the third shirt, since it is blue, it says true, but all the other ones are false. I think I have like a bit more time, so I'll also try to show you how this does not work. So if I want to print spec.sizes with JSON path, I've not tried this before, so I'm going out of my routine here. So I'll try to apply this CRD now, and if I try to get shirt, yeah, this still comes up, but see in this case how it has an empty value. We are trying to query the multiple like the field that has multiple values using JSON path. In this case, it does not print any value. So if we want to show an empty value, we can use CEL to do that. And like for sure, JSON path does not let you like write complex CEL expressions. So this is like a quick demo of what is possible with CEL. Yeah.
What would be a case where you wouldn't use a string here as a type? You're using strings across the board, even though
Right.
you'd be leaning towards actually giving it another type.
Right.
Can you repeat his question so that the stream can pick it up?
Yeah.
Yeah, I was just curious about the use of string types across the board here. Is there a use case for actually doing something different there and extending it to even arrays or a list of integers or something along, so you can do something more sensible with that data?
Yeah. So here, when we say type string, in the case of JSON path expressions, I think that there are a list of types which are defined, which you can like use here for additional printer columns. And in the case of JSON path, most of it is just querying data from the CRD spec, so most of them are strings. But in the case of CEL expression, here when we say string, the CEL expression itself has to like evaluate to a value that is a string type. So if we should be able to extend it so that we can write a CEL expression that would. So here what happens is, even though we are evaluating to a Boolean type, that value is converted to a string so that it can be printed in the, like there is a table converter.go file which would convert those values so that it can print it in this format. So there is like I'm not sure if that is how it works, like whether the like even if the cell expression does not evaluate to a string, it is converted to a string, like that value is converted to a string at the end. But if we have like today we have like different decal types for cell. I don't have a slide for that, but we have like declared types for CRDs, like the CRD fields which are used in cell. Like they've added support for that in cell. So you have types like IP address, CIDR block, and semver, and so on, which are used in different parts of Kubernetes. Like DRA, for example, uses semver and IP addresses. So you can essentially make a cell expression evaluate to a IP type, and then you can like work with them. But here, I don't think it really matters because ultimately it's just printing the value, so everything gets converted to a string at the end.
Thank you.
Thank you. Yeah, so that is a quick demo of how it works. Like all the examples that I've used here are like fairly simple, but as I said, we have a lot more types and a lot more things that we can do. Like just having the ability to run any expression that you want lets you do a lot of things. And yeah, this is like all the issues that we saw earlier would be resolved now that we have cell. So yeah, this was a quick example in case the demo didn't work. But here are a list of resources where you can learn more about cell. Google has a good code lab where you can walk through the initial example that we did, where we'll take a simple hello world cell expression and then we'll write Go code to compile it and evaluate it against the input and so on. There is also an issue called a wish list of cell libraries. This is an issue in the Kubernetes repository where people talk about how they're using cell and what they want in cell that is not already there in Kubernetes today. So if you are interested in contributing to Kubernetes in this particular area, this is something that you'd be interested in. Yeah, then the Slack channel and everything. And yeah, I also have a blog. So this is kind of like a shameless plug. I have a blog where I write about how I like develop like features for Kubernetes, like how I run Kubernetes locally and so on. So if you're interested in that sort of thing, you can take a look. And yeah, this QR code gives you this slide deck, and you can like contact both me and Priyanka. So we've been working on like whatever demo that we showed here today. Priyanka and I have been working on like all the code that goes behind doing the cell compilation for CRDs. Yeah, we've been working on that for the past 8 or 10 months now. And yeah, if you're interested to talk to us, you can message us on Slack, or we'll be there at KubeCon also, so you can come talk to us. Yeah, that's the end of my slide.
Any questions? Yep.